week we're going to be talking about logarithms, but before we can do that, you need to know a couple more exponent rules. The first has to do with negative exponents. I've started a table where I'd like you to observe the pattern. So the table starts at 3 cubed and the exponents go down 1 each time. You can see the negative exponents appear, and the question is, what are those equal to? Well, look for the pattern. As the exponent drops by 1, the value of that expression, remember 3 cubed is 3 times 3 times 3, which is 27, and 3 squared is 3 times 3, which is 9, the value ends up being divided by 3. Drop 1 more, and the same thing happens. So to figure out what 3 to the 0 should be equal to, if I lower the exponent by 1, I need to divide my last number by 3. 3 divided by 3 is 1. Now, if I lower my exponent to a negative 1, I have to take 1 and divide it by 3, which gives me the fraction 1/3. And you'll notice I also wrote that as 1 over 3 to the first power, again, to encourage you to see the pattern. Divide by 3 again, you get 1 over 9, which is 1 over 3 squared. If you take a third and divide it into 3 pieces, it's 1/9 of the original. And if we do that again, if we take 1/9, divide that into 3 pieces, the result is 1/27 of the original, or 1 over 3 cubed. So 3 to the negative third becomes 1 over 3 cubed. Notice all that really happened is that the 3 to the negative 3 moved to the denominator of a fraction. When it does, the exponent turns positive, and the numerator became a 1. That's the general rule. For any x to a negative exponent, negative n, that will always be equal to a fraction. It'll be 1 over x to the positive n power. Just to give you an example, if I needed to know what 5 to the negative 2 is, it would be 1 over 5 squared, or 1 over 25. So this is the first rule I need you to know. The next has to do with fractional exponents. And the explanation for these is a little bit longer than I want to get into. So again, we're going to take an observing of patterns approach. So the square root of x, it turns out, is the same as a fractional exponent of 1/2. This is x to the 1/2 power. I'm going to rewrite that, but throw in some extra information. Remember, a square root has a 2 as its index. On that little scoopy part, as I like to call it, we usually write the number of the root. Square root is the only one we don't write, and we use a 2 to represent that idea of squaring. I also, underneath the radical, because my x did not have an exponent, that exponent would be 1. So I wrote that. We'll take this version. Now I'm going to tell you that the cube root of x is the same as x to the 1/3 power. Now my index on my radical is there, my little 3 sitting on the scoopy part. I'm going to throw that 1 on the x under the radical again. And another example. Here I have the 4th root, put on that exponent of 1. Are you starting to see the pattern here? I'm going to throw a different one at you. If I had the 5th root of x squared, it would become x to the 2/5 power. The general rule when working with fractional exponents is that they represent radicals. The index of the radical, the m, is the part on the scoop of the radical symbol, and n would be the exponent on what's underneath. That's equivalent to saying x to the n over m power. This is the second rule I need you to know. Now we're ready to talk about inverse functions. Let's use some basic ones you're already familiar with. If I have the number 3 and I add 2 to it, I get 5. If I want to undo that, what would I do? I'd subtract 2, right? Subtracting 2 undoes adding 2, and that's because addition and subtraction are inverse functions. Another example, if I take 4 and square it, I get 16. How would I undo that? How would I start with 16 and turn it back into a 4? I would do that by taking the square root. Squaring and taking a square root. Suppose we have an exponential equation like y equals 2 to the x power. I have set up a table of values where I'm going to substitute different values of x into that equation. Next, I'm just going to evaluate those expressions on the right, and I get these values for y. So for the input, x equals 1, I get an output where y is 2. 2 becomes 4, 3 becomes 8. So what I did is I took the x value and I made it the exponent on a base of 2. How do you undo that? This is really what I'm asking you. Imagine starting with those y values of 2, 4, and 8, and what could we do that would turn the 2 back to the 1 we started with, the 4 back to the 2 we started with, and the 8 back to the 3? Now you might have thought dividing by 2, but that only works for the first 2. That doesn't hold true for 8. We need a rule that works for everything. And the thing that works for everything, in other words, the inverse operation for making x an exponent, is logarithms. A logarithm takes you back to the x, which was the exponent. And that's because, and here's the phrase that you just want to memorize and say in your head over and over again, a logarithm is an exponent.